Now let's look at limits of the form infinity times 0, either plus or minus infinity. Now, that form is indeterminate, right? I mean, it's not the number 0, remember. We're talking about something headed to 0 and something headed to infinity. So when you multiply them, the thing headed to 0 wants to make that product go to 0. The thing headed to infinity wants to make that product get very, very big. And so it's indeterminate as to who's going to win that race. So we need to do something with it. Well, thankfully, you can get that into an infinity over infinity or 0 over 0 form just with a little algebra manipulation. And let's just see how that's done with an example. So say we were taking the limit as x approaches 0 from the right of x times natural log of x. And I'm approaching from the right because it doesn't make any sense otherwise, right? Natural log is only defined on the right-hand side. But remember, as you come in from the right on natural log, you go down to negative infinity. So the form here is 0, because x is headed to 0, times negative infinity. So we aren't sure just by looking at it what that limit is. But algebraically, we could take the reciprocal of either one of those functions and put it on the bottom. And then we would have a fraction of the form 0 over 0 or infinity over infinity, depending on which one we decided to flip. Either one would be a form that L'Hopital's rule can handle. Now, typically, one of those ways will get you towards the answer. One will just make things more complicated. And the general rule is do the thing that looks easier. So I would much rather differentiate 1 over x than 1 over natural log x, because 1 over x is a simpler function. So that's the one I'm going to flip. And you'll know if you chose incorrectly, because after you do L'Hopital's rule, you'll have something that is even more complicated than what you started with. So algebraically, these things say the exact same thing, right? Because that's 1 over x, which is just x. So those two expressions are the same. But written like this, we have something of the form negative infinity over, now as x gets closer and closer to 0, remember 1 over x blows up to infinity. So we've turned it into an infinity over infinity situation. One of them is negative, one of them is positive. That's OK. Remember, any ratio of infinities, L'Hopital is fine. And so now we're ready to apply L'Hopital. So you have to get it in that form. There is no sort of common misconception is, well, I can just invent some sort of L'Hopital's rule where I take the product rule or something there. But you can't do anything with the limit as is. You have to get it in a 0 over 0 or infinity over infinity form first. But then you're free to apply L'Hopital's. So derivative of natural log, 1 over x. On the bottom, we just have power rule, right? So x to the negative 1, differentiate that. And as always, I want you to quote L'Hopital there. And when you simplify that, now you could just flip that back. So it's not a complex fraction there. That simplifies down just to negative x. And that limit is not indeterminate. That's a simple limit. That limit is just 0. So what we're seeing here is that this term is pulling this product to 0. This term's pulling this product to negative infinity. But x is winning. It's getting closer to 0 in some sense faster than natural log is going down to negative infinity. So that product gets closer and closer to 0.